Hello everyone, so let us learn how to solve, this time, linear differential equations. So we have right here two differential equations. On the left side, this is a linear differential equation of order 1 with respect to x in the dependent variable y. So the dependent variable here is y, and the independent variable here is x. So on the right side, this is still a linear equation of order 1 with respect to y in the dependent variable x. So both equations right here are linear equations of order 1. So if we divide both sides of the equation by a of x, the equation here on the left side, if you're going to divide this, let me write that. Let's divide by a of x. So when we divide this equation by a of x, we are going to get dy dx plus p of x times y equals q of x. So this p of x right here is b of x divided by a of x, and this q of x right here on the other side of the equation is c of x divided by a of x. So this equation right here now is our standard form of the linear equation. Again, this is the standard form. Now the standard form of the other equation on the right side can be obtained if we are going to divide. We're going to divide by a of y. So dividing by a of y, we get dx dy plus p of y, this time is a function of y, times x equals q of y. So just like earlier, p of y here is b of y divided by a of y, and q of y right here is c of y divided by a of y. So this is also the standard form, but this time the independent variable is y and the dependent variable is x. Now how do we solve these linear differential equations? So let's just focus on this equation right here on the left side. Alright, so what we're going to do is to multiply both sides of the equation by dx. So multiplying both sides of the equation by dx, we have dy plus p of x times y dx equals q of x dx. I hope that you were able to follow that one. We multiply both sides with dx. After that, we are going to group together all the terms containing dx, so we're going to transfer this to the other side. So we are going to factor it out. That's p of x times y minus q of x dx plus dy equals 0. So this dE right here is an inexact dE. And for us to be able to make it exact, remember, to make it exact, we multiply it with an integrating factor v. So this is inexact. So multiply with v. So remember, this v right here is the integrating factor. Let me just write IF, integrating factor. So upon multiplying with the integrating factor v, so that's v times p of x times y minus q of x dx plus v dy equals 0. So after doing that, this is considered to be already exact. And because this is exact, then our m right here, m of xy, let me just use m, is equal to vy p of x. We just multiply that here, that's vy p of x, and then minus v q of x, right? And n right there is equal to v. And so because it is already exact, we expect that the partial of m with respect to y is equal to the partial of n with respect to x. And so taking the partial with respect to y of vy p of x minus v q of x is equal to the partial with respect to x of v. Okay, this is our m and this is our n. So remember, because we are taking the partial with respect to y, all other variables are treated as a constant. So meaning v here and x here are constants, and because we have y here, then the partial there is just the other variables. So that's v p of x, right? And because there is no variable y here on this term right here, then its derivative with respect to y, its partial with respect to y, is just equal to 0. So the term remaining on the left side is just vp of x. Let me just put it closer to the equal sign. So that's vp of x. And on the right side, because we are differentiating with respect to x, then this is dv divided by dx. Okay, so cross multiplying to group, this is already a VSDE, so p of x dx is equal to dv divided by v. And so we want to integrate. So integrating, the integral of dv over v is ln of v. On the left side, we simply write p of x dx. And on the right side, that is equal to ln of v. And remember that when you have ln of v, that's just like log of v with base e, right? So therefore, v is equal to e to the integral of p of x dx. So this one right here is already our integrating factor. That's our integrating factor. So on the other hand, if our, for the other dE right here, if our dependent variable is x, then our integrating factor would be, e to the power of the integral of p of y dy. Okay, so that is already our integrating factor. Let me erase that because we're going to focus on the dE whose dependent variable is y. The independent variable here is x. So because that is already our integrating factor, we're going to multiply the integrating factor to the inexact dE. Okay, so multiplying that to the original. Okay, our original, let me write that again, is, we're going to replace the v. Okay, so let me just write it again. Our dE earlier, that was vy p of x dx minus v q of x dx plus v dy equals 0. So let us replace v here with the integrating factor e to the integral of px dx. So e to the integral of p of x dx y p of x dx minus e to the integral of p of x dx q of x dx plus e to the integral of p of x dx dy equals 0. So we are going to leave the dx dy on the left side. I want you to take a closer look. This term right here and this term right here. Okay? So we're going to group that together. This term. So we are going to group them together. So that's e to the integral of p of x dx y p of x dx plus e to the integral of p of x dx dy equals, and then this term we are going to transfer to the other side of the equation. That's equal to e to the integral of p of x q of x dx. Now this term right here on the left side, this right here, is actually an exact differential of y e to the integral of p of x dx. Okay, so it's an integrable combination because when you find the differential here, you copy y, take, diba, the derivative of this one, and then copy this, and then derivative of y, or differential of y, which is dy. So it's an exact differential. I mean, it's an integrable combination rather. So that term right there is actually just equal to the differential of y e to the integral of p of x dx. That's equal to e to the integral of p of x dx q of x dx. And so therefore, integrating, taking the integral of both sides, so integrating both sides, we have on the left side, we have y e to the integral of p of x dx, and on the right side, in integral of e to the integral of p of x dx q of x dx plus c. This is now our general solution. So if you want to remember, or you want to recall, no, that this is our integrating factor. So on the left side, you have y times the integrating factor equals the integral of the integrating factor times q of x dx. And remember that the integrating factor is e to the integral of p of x dx. So if that is when our independent variable is x, meaning that's dy dx. Pero if baliktad, if it's the reverse, if it's dx dy, then remember that our integrating factor, okay, let me just write this. Okay, if our dE is in the form dy dx plus p of x y equals q of x, then the integrating factor is equal to e to the integral of p of x dx. And our solution is y times the integrating factor v equals the integral of the integrating factor times q of x dx plus c. But if it was dx dy, okay, plus p of y times x equals q of y, then our integrating factor is equal to e to the integral of p of y dy. And our general solution would be x times the integrating factor equals the integral of the integrating factor times q of y dy plus c. Okay, so these are the things that you just need to remember if we are to solve linear differential equations. So remember that we can only treat a DE as linear if we are able to write it or write them in these forms. So for example, we want to find we want to solve 2 times y minus 4x squared dx plus x dy equals 0. As you can see here, obviously this DE is not, it's not separable, it's not homogeneous either, and obviously it's not exact, so meaning it is inexact. So you can solve this as an inexact DE. However, you can always try to see if you can change it into the linear form. Okay, so usually what we do, what we notice if you want to change to in a linear form is that for the differential with a more simple coefficient like this one, this is dy right here, x is more simple, then usually it is that differential, or it's this variable right here, which is the dependent variable. So kumbaga, in the dy dx form or in the dx dy form, siya yung ang nasa numerator. So because si n ang simple, so we're gonna divide both sides by 2y minus 4x squared, or divide both sides by dx rather. So this would now be 2y minus 8x squared. We just distributed 2 right there. Distribute natin 2. And then we are going to divide x dy over dx equals 0. And then to remove x from there, we're going to divide again by x. So that's 2y over x minus 8x plus dy dx equals 0. And then we are going to rearrange it since the form is dy dx. So dy dx plus, we're going to write this as 2 over x times y equals 8x. So this right here is this one, and because this is negative, when we transfer to the other side, it becomes positive. So this is now in the linear form. And it's very important if it's already in the linear form, diba? It's dy dx plus p of x y equals q of x. Always remember that. So, bale, it's very easy to recall na if our dependent here is y, then the extra variable here is also y. So, we identify our p of x. So, our p of x is 2 over x, and our q of x is equal to 8x. And it's very simple. Once you have that, you now can solve for the integrating factor. So, the integrating factor, therefore, is equal to e to the integral of 2 over x dx, which is equal to e to the power of 2 ln of x, and so the integrating factor is equal to x squared. And so now solving, remember how to solve. We start with it's y times the integrating factor equals the integral of the integrating factor times q of x dx plus c. So substituting, just the variable y, multiply it to the integrating factor x squared equals the integral of x squared times our q of x, which is 8x dx plus c. So x squared y equals the integral of 8x cubed dx plus c. Simplifying or integrating, it's now 2x to the power of 4 plus c. That's x squared y. Therefore, our solution is x squared times y minus 2x squared equals c.